Yesterday we talked about the various properties of logarithmic expressions, and today we're going to combine exponential and logarithmic expressions together to solve equations. So both exponential and log equations have what we refer to as the one-to-one property, and this allows us to easily convert and solve between each of the types of equations that you'll be working with today. So for exponentials, if you have two exponential expressions that are set equal to each other and they have the same base, then we know that their exponents are equal. That's your one-to-one property for exponentials. For logarithms, they too have a one-to-one property, and so we have log base a of x is equal to log base a of y. If you have two logarithms set equal to each other with the same base, then your logarithmic expressions are equal to each other. This was one of the properties we discussed yesterday. In addition to that, we also have our inverse properties, and there are two different inverse properties that you work with depending on the base that you're working with. So if you just have a standard base a or a common log where you have a base of 10, then your inverse property for a log base a of a to the power of x is just x. And your inverse property for the exponential of a raised to the power of log base a of x is going to be just x, because exponents and logarithms are inverses of one another, so they undo each other. If you have a natural base e, we talked about this number yesterday, your natural base e, it has a value, it's approximately 2.7178. It has a key on your calculator. You need to learn where it is and how to use it. Your inverse property for your natural log, if you take the natural log of base e to the power of x, then this is just going to be x, again, because natural logs and natural base e's are inverses of one another. And then if you raise base e to the power of the natural log of x, then again, your result is just going to be x. Now, when you solve exponential and logarithmic equations, you are doing essentially the same thing, but it depends on what type of equation you're given and how you go about solving it. So if you start with an exponential expression, then the very first thing you want to do is isolate the exponential so that you have the exponential expression on one side and everything else on the other side. And then once you've done that, you're going to take the log of both sides, because the logarithm is going to undo the exponential. For logarithmic, you're going to isolate the logarithm just like you would if it were an exponential. So you want the log on one side and everything else on the other. And then to undo the logarithm, you exponentiate both sides. So that means you're going to use the property that if you have a to the power of x equals y, then this is the same as saying log base a of y equals x. So you're going to have to exponentiate your log, because this goes backwards and forwards. This is what we call a biconditional. So it's true if you're moving from left to right, or if you're moving from right to left, it holds. So let's work through a few examples for your notes before you get into the practice set. So the first example is very much like what we were doing yesterday, where we're just giving the exponential and we're asked to solve it. Now you can solve this just like we did yesterday, where you end up working with the same base of the exponent, but just to practice with the logarithmic process, the first thing you check is that your exponential expression is on one side and everything else is on the other. In this case, that's true. So then I'm going to rewrite both sides as a logarithm. And so what that looks like is I'm going to have log base 4 of 64 is equal to x plus 2. Because if I take the log base 4 of 4 to the x plus 2 power, that's just going to give me x plus 2 anyway. And then once I'm here, all I have to do is solve it. So I have x is equal to log base 4 of 64 plus 2. Now, this is the part at which you have to use your calculator. And so when you are working with your calculator, the way that you access your log base is you're going to hit Math, and then you're going to press your up arrow twice, and it's going to give you log base. So this is going to allow you to put any log base into the calculator. So I have log base 4 of 64 plus 2. And so my answer is going to be 5. Will it always be this neat? No. Odds are you're probably going to end up with a decimal answer more times than not. For number 2, here we're dealing with a natural log. So in order to deal with a natural log, you have two options. You can either rewrite it using log base e, or you can just remember that your natural base e is the inverse of a natural log. So when I exponentiate both sides, I'm really just, and for this one, you don't even have to exponentiate both sides because we have a natural log equal to a natural log. And that means our expressions are equivalent to each other because of the one-to-one property. So to save us a little bit of work, we'll just use the one-to-one property instead of exponentiating, and we'll exponentiate in a few more of the following examples. So we add 3, and this gives me 2x is equal to 14, and x is equal to 7. Okay, so to give you one that's a little bit more complex, but still in the relatively easy realm, we have 5 plus e to the x plus 1 power equals 20. So when we say isolate the exponential, you want to get this term by itself. So to do that, I'm going to subtract 5 from both sides, and this gives me e to the x plus 1 power is equal to 15. And then once I'm here, I have to take the logarithm of both sides. So if I rewrite this using logarithms, then it's going to be log base e, but I know that log base e is a natural log. So I have the natural log of 15 is equal to x plus 1. And then from here, I'm solving for x. So I have x is equal to the natural log of 15 minus 1. Now you have a natural log key on your calculator, and the way you access it, if you look just under the log key on your calculator, you have ln. So this log key is used for common logs where you have a base of 10, and the ln is used for natural logs. If you don't have a common log or a natural log, then you have to use the math and go to the log base to access the appropriate program for your calculator. So all I do is I let the calculator do this work for me, making sure that I group things in parentheses accordingly. And this is going to give me approximately 1.7081. And what I want you to do is I want you to always round off to 4 decimal places instead of rounding off to the first decimal place. So you're always going to have 4 decimal places past the decimal. So this is approximately equal to 1.7081. Okay, now let's try a logarithm where we have to exponentiate. And so for example number 4, we have 2 times log base 4 of x is equal to 5. So with this one, the very first thing that I need to do is divide both sides by 2. So I have log base 4 of x is equal to 5 over 2. And then I'm going to exponentiate both sides. So that means I'm going to rewrite using an exponential. So this is going to be 4 to the 5/2 power equals x. And then at this point, I let the calculator do the work. And so x is going to be equal to 32.